Hello dear students, today we are going to solve some more numerical problems on DC current electricity. First question is, in the given diagram, find the values of current I2, resistance R and EMFs E1 and E2. This is the question. Now solution. At junction C, Kirchhoff's current law gives I3 and I1 are incoming currents and I2 is outgoing current. Therefore, I2 will be equal to I1 plus I3. That is 3 plus 3 is equal to 6 ampere. Now, KVL, Kirchhoff's voltage law, on outer loop containing R, R1, R3 gives I into R plus I1 into R1 minus I3 into R3. I3 into R3 is equal to 0. Two into R plus 3 into 4 minus 3 into 6 is equal to 0. This gives 2R is equal to 18 minus 12, 6. Therefore, R will be equal to 3 ohm. Suppose this is loop 1, loop A, and this is loop B. In closed loop A, KVL gives sigma EMF is equal to sigma IR. So, E1 is equal to I1 R1 plus I2 R2 I1 3 into 4 plus I2 has been calculated to be 6 ampere. 6 into 3, which is 30 volts. Now, KVL in closed loop B gives sigma EMF means E2 is equal to sigma IR I3 R3 plus I2 R2 3 into 6 plus I2 has been calculated as 6 into 3. This is 18 plus 18, that is 36 volts. Second question is, equivalent resistance in series and parallel combination of two resistors are 6 ohm and 4 by 3 ohm respectively. Find the values of two resistances. Solution. In series, equivalent resistance Rs will be equal to R1 plus R2, that is 6 ohm, and in parallel 1 upon R parallel is equal to 1 upon R1 plus 1 upon R2. LCM is R1 R2, here R1 plus R2. This gives R parallel is equal to R1 R2 upon R1 plus R2. R1 R2 and R1 plus R2 is 6. Rp is given to be 4 by 3. This gives R1 R2 is equal to 6 into 4, 8 ohm. Now R1 minus R2 will be equal to R1 plus R2 whole square minus 4 R1 R2. Therefore 6 square minus 4 R1 R2 means 8 into 8. This is 36 minus 32 under root 4, which is 2. Thus R1 plus R2 is equal to 6 and R1 minus R2 is 2. On solving these two, we get 2R1 is equal to 8. Therefore R1 is equal to 4 ohm and R2 is equal to 2 ohm. Third question is, a galvanometer having resistance 100 ohm gives full scale deflection for 5 milliampere. Find the value of shunt resistance needed to convert it into ammeter of range 1 ampere. Solution. Shunt resistance, yes, shunt resistance is given by the relation S is equal to Ig into Rg upon I minus Ig. Here Ig is the current for full scale deflection. Here Ig is 5 milliampere, which is 0.005 ampere. Rg is resistance of galvanometer 100 ohm and I is 1 ampere. So 0.005 into 100 upon 1 minus 0.005, which gives 0.5025 ohms. Next question is, a galvanometer having resistance 10 ohm gives full scale deflection for 0.01 ampere. How would you convert it into a voltmeter reading 120 volt for full scale deflection? Solution. We must connect resistance are in series with galvanometer. Where R is V minus Ig into Rg upon Ig. Here V is 120 volt, 120 minus Ig is 0.01, Rg is 10 upon 0.01. On simplification it gives, if you remove this decimal, you get 12,000 minus, this cancels, minus 10, which is 11,990 ohm. This is 2 into 2 minus 1, which is 2, that therefore R will be equal to 2 ohm. Next question. A wire of resistance 4 ohm is stretched to twice its original length. Find the resistance of the stretched wire. Solution. As the volume of wire before and after stretching remains constant, therefore A into L will be equal to A dash into L dash. This is A dash into L dash is 2L. This gives A dash is equal to L cancels, and A dash gives A by 2. Now R dash will be equal to, this is resistance of stretched wire, rho into L dash upon A dash. This is rho into L dash means 2L, A dash means A by 2. So this is 4 into rho L upon A, which is R. 4 R means 4 into 4 is equal to 16 ohms. Next question is, find VA minus VB in the given circuit. This is the given circuit diagram, and we have to find the potential difference between points A and B. First we find the resultant resistances. Resultant resistance between A and B will be given by 1 upon R AB is equal to 1 upon 10 plus 1 upon 8. LCM is 80, and 8 plus 10 means 18. Therefore RAB will be equal to 80 upon 18, which is 4.4 ohm. Similarly, resultant resistance between B and C will be given by 1 upon R between B and C will be 1 upon 10 plus 1 upon 18 plus 1 upon 25. LCM is 450. This is 45. 450, 45 plus 25 plus 18, which is 88 upon 450. This gives R between B and C as 450 upon 88, which is 5.1 ohm. Now current flowing in the circuit will be I is equal to E upon total resistance of this plus this in series, R between A and B plus R between B and C, that is this is 10 volt. So 10 upon 4.4 plus 5.1, that is 10 upon 9.5. I is equal to 1.05 ampere. 05 ampere. Therefore, B A minus B will be equal to I into this resistance. So I into R between A and B. I is 1.05 and RAB is 4.4. So it gives 4.62 volts. In the next question, the question is, the given figure shows the balanced meter bridge in which L1 is to L2 is 3 is to 2. Find the resistance per unit length of uniform wire of length 1.5 meter used for resistance P. Means this resistance P is in the form of a wire of uniform cross section area and length 1.5 meter. We have to find the resistance per unit length of this wire. Solution: because the meter bridge is balanced, therefore for the balanced meter bridge, P upon Q is equal to L1 upon L2. Here L1 upon L2 is given to be 3/2. This means that P will be equal to 3Q upon 2, that is 3 into Q is 10 upon 2, which is 15 ohm. Therefore, resistance per unit length will be equal to, resistance is P and length is 1.5 meter, means 150 cm. So 15 upon 150 ohm per cm, that is 0.1 ohm per cm. Next question is, in the given circuit, find VA minus VB. Suppose this point is P. Between A and P, these three resistances are in parallel. Therefore, 1 upon R between A and P will be equal to 1 upon 6 plus 1 upon 6 plus 1 upon 6, means 3 upon 6, which is 1/2. This gives R between A and P as 2 ohms. Similarly, 1 upon R between P and B will be equal to 1 upon 6 plus 6, 3 12, 1 upon 12 plus 1 upon 12, this is 2 upon 12, 1 upon 6, which gives RPB is equal to 6 ohm. Now this is 2 ohm and this is 6 ohm. Therefore, B A minus B will be equal to I into R between A and P plus R between P and B, that is 0.5 into 2 plus 6, 8 into 0.5 means 4 volt. Number 10. In the given circuit, find the voltage across 12 ohm resistance. We have to find the potential difference across 12 ohm resistance. Suppose this is point A, this is point B, and this is point C. Then resultant of these three resistances in parallel will be 1 upon R between A and B, 1 upon 8 plus 1 upon 8 plus 1 upon 4 means LCM is 8, 1 plus 1 plus 2 means 1 by 4 by 8, 4 by 8 which is 1 by 2. This gives RAB is equal to 2 ohm. Now this 2 ohm and this 4 ohm are in parallel. So the resistance of upper branch is 6 ohm and the resistance of lower branch is 12 ohm. In parallel, voltage between A and C will be same through all branches. Therefore, I1 into RAB plus 4 ohm will be equal to I2 into 12 ohm. That is I1 into this is 2, 4, 6, 6 is equal to I2 into 12. This cancels 2. This means that I1 is equal to 2 I2. Junction A, KCL gives I is equal to I1 plus I2, that is I is 12, 2 I2 plus this I2, 3 I2. Therefore, I2 will be equal to 12 upon 3 means 4 ampere. Therefore, voltage between A and C will be equal to BAC is equal to I2 into 12, that is 4 into 12, 48 volt.